All right, let's talk about a classic iOS headache. We're diving into the view controller lifecycle, but with a pretty big twist. We're going to look at what happens when you throw a navigation stack into the mix. Getting this right is huge. It's basically the difference between an app that feels kind of buggy and one that feels super smooth and professional. I mean, if you've ever written an iOS app, you have definitely asked yourself this question. We've all been there, right? You push to a new screen, maybe you edit something, you tap back, and the data on the first screen is totally stale. It's such a common bug, and it's so frustrating. But stick with me, because by the end of this, you're going to know exactly why that happens, and, even better, how to fix it for good. Okay, so before we can really get into the weirdness of the navigation stack, we got to make sure we're on the same page with the basics. Let's do a super quick refresh on the standard lifecycle for just a single lonely view controller. Yeah, you probably know this stuff in your sleep. A view controller gets created with init, its view loads, it's about to appear, then it does appear, and on the way out, it's about to disappear and eventually gets deallocated. It's this really clean, really predictable journey, from birth to death. But this whole perfect little cycle gets thrown completely out the window the second you wrap it in a navigation controller. And this is where things get really interesting. The moment you embed your view controller inside a UI navigation controller, well, those simple, straightforward rules we just talked about, they get a serious twist. The stack literally changes everything. So the absolute best way to think about a navigation stack is like a deck of cards, seriously. You can only ever see the card that's on top. When you add a new card, that's what we call a push. And when you take that top card away to see the one underneath, that's a pop. Just keep that stack of cards idea in your head through all of this, because it is the absolute key to understanding how this all works. Okay, theory's great, but let's actually see this thing in action. We're going to walk through the two main things you do with a navigation stack, pushing a new screen on and popping it off, and we'll watch exactly which lifecycle methods get called and when. So first up, the push. Imagine we're on screen A. The user taps a button and we want to show screen B. So screen B is about to get pushed right on top of our stack. Okay, pay close attention to the order of events here, because this is where the magic happens. First, look at screen A. It gets viewWillDidAppear, and then viewDidDisappear. It knows it's about to be hidden. Then, and only then, screen B comes to life. It gets its view loaded, then viewWillAppear, and finally viewDidAppear. But what's the most important thing that didn't happen to screen A? Did you spot it? There's no init call. And that right there is the most important thing to understand. Screen A is not gone. It hasn't been destroyed. It's just, well, it's kind of sleeping. It's still hanging out in memory, just waiting patiently underneath screen B. Exactly like that card that's now hidden in our deck. All right, so what about coming back? The user's finished with screen B, they hit that back button. Now we're popping screen B off the top of the stack to get back to screen A. So let's follow the sequence again. This time, screen B is the one saying goodbye. It gets viewWillDisappear, then viewDidDisappear, and then, and this is the key part, bam, dinit gets called. Screen B is officially gone, completely removed from memory. At the same time, screen A, which has just been chilling in the background, starts to wake up. Its view is already loaded, so it doesn't need viewLoaded. Instead, it just gets viewWillAppear and viewDidAppear as it comes back into view. Now, it's super important to realize that this stack of cards behavior is specific to navigation controllers. It's a totally different beast from, say, presenting a screen modally. To the user, yeah, a new screen appears. It might look kind of similar, but under the hood, their life cycles are night and day. So let's break it down. On the left, with a push, you're usually moving deeper into a hierarchy of information. Think of a settings menu. You keep the previous screens in memory so you can easily go back. But on the right, a modal is for a totally separate, self-contained task, like composing an email or picking a photo. When you're done, you dismiss it, and that screen is typically just gone from memory. They're really just two different tools for two very different kinds of jobs. Okay, so that's all the theory, but who cares, right? How does this actually help you write better code? Let's bring this all back to the real world and see why this stuff actually matters in your everyday coding. Let's go all the way back to that first problem we talked about, the stale data. The solution is almost always viewWillAppear. Because this method gets called every single time a screen is about to show up, not just the first time, it is the absolute perfect place to refresh your data. It's also great for starting animations or firing off network requests that you only want running when the user can actually see the screen. And just knowing which screens are still alive in that stack helps you manage your app's memory way better and avoid some really annoying bugs. So, I'm going to leave you with a question to think about. Go back to your own projects, think about those screens where you've seen stale data, or maybe some animation that doesn't restart correctly. Now that you've got this deeper understanding of the navigation lifecycle, where in your code can you use viewWillAppear to make your app that much smarter, cleaner, and just better